Hello everyone, here there is a question. Says a photon of wavelength lambda is incident on a free electron at rest and is scattered in the backward direction. The fractional shift in its wavelength in terms of Crompton's wavelength lambda c of the electron is. So shift, fractional shift, we have to find the fractional shift. First of all, we have to know about the Compton's rule. So Compton's is worked with the X-rays. Okay, so whenever a photon, so this is going to be, I am drawing here the photon, this is going to be the photon. Whenever the photon is going to be incident and hit an electron, so it's going to produce an individual, okay, individual electromagnetic wave. What is the electromagnetic wave here produced is, yes, X-rays. So here it is going to produce X-rays. So we know that X-ray, how that's the X-ray produces. Okay, so this is the X-ray actually moving on towards that direction, and this electron get diverted in this direction to get recoil. So to get recoil, so they lost some electron, lost some energy. So due to this hit of the photon, so it's going to recoil in this direction, so to regain their energy. Okay, so now this photon is going to become with an energy of E is equal to hc by lambda. So comes the energy, that is a lambda, it's the lambda. Okay, okay, and then it going to be produce an angle. Actually the photon comes this direction, straight direction, right, but it diverges in angle theta. So this is also going to be theta, same theta. Okay, so here wavelength, so here the energy remains is E dash is equal to hc by lambda dash, lambda dash. So here we get change in the wavelength between the incident photon and the produced X-ray. Okay, X-ray is also here, it's going to consist of photons, some photons. Okay, so this change in lambda, this lambda is changed to lambda dash. Okay, this change in the wavelength, first it is incident with the wavelength of lambda and it converted into lambda dash. This change in this both wavelength is equal to h by mass of this electron which is present here into c. C is velocity of light into 1 minus cos theta. Where is theta? What is this theta? So this is the angle of divergent. Okay, actually the photons travels in the straight direction, but it is going to divert in a direction, that is angle of theta. Okay, from its original direction. So this is the Compton's formula. So they were asked, so they told that a photon of wavelength lambda, yes, lambda is incident on a free electron at rest and scattered in the, so it is scattering in this direction. Actually in this situation it is scattering, X-ray is produced. X-ray means it is also consists of photon. Okay, so this is going to be, yes, scattered in angle theta, scattered in backward direction. So what it means actually? So it comes, hits and goes backward direction. So it means the divergent, the angle of divergent is 180 degree, right? It goes backward. It means it diverges in 180 degree. So theta is equal to 180 degree. So here theta is equal to 180 degree as per the question given. Okay, and the fractional shift in its wavelength in terms of Compton's wavelength. Okay, Compton's wavelength. What is the Compton's wavelength? Compton's wavelength lambda c is equal to h by mc. So De Broglie, Compton, they are said the same thing. Okay, Compton's wavelength is h by mc. Okay, even the De Broglie told the same wavelength. Okay, same the equation. Okay, so I am going to substitute this here. Yes, h by mc. Here also h by mc. Okay, so here the mass of particle is going to be represented, but here the mass of electron is going to be represented. Okay, Now 1 minus cos theta, theta is equal to 180 degree. We are going to substitute this thing also. So I am going to next page for the further classification, sorry, further simplification. Lambda is equal to, what we have wrote here is h by mass into velocity into 1 minus cos theta. So this is the not de Broglie's Compton's equation. Okay, so according to the Compton's wavelength, okay, change in wavelength is equal to Compton's wavelength. So h by mc is going to Compton's wavelength. As per the question, the Compton's wavelength is written as lambda c. So 1 minus cos 180 degree. So cos 180 degree. So we know that cos 90 degree, sorry, the thing was not good. Cos 90 degree is equal to 1. Then cos 180 degree is going to be, okay, cos 180 degree is going to be minus 1. Okay, I'm going to substituting this value here. So the change in wavelength is equal to, so Compton's wavelength, okay, 1 minus minus 1. So minus into minus plus, so 2, 1 plus 1 2 lambda c, which is equal to change in wavelength of photon. Okay, so we have found the shift. So shift in, okay, wavelength, okay, change in wavelength, but here they asked fractional shift, fractional wavelength. Okay, so I'm going to divide lambda on both sides. By dividing lambda on both sides, this is known as fractional shift. This is going to be the shift in wavelength. This is going to be the fractional shift, which I am drawing the box is the fractional shift. 2 lambda c by lambda is going to be the answer for this question. So lambda shift, fractional lambda shift is going to be equal to 2 times the Compton's wavelength by lambda. So where is the answer is going to be lambda c by 2 lambda? No, that is option D is the correct answer for this question. 2 lambda c by lambda. Thank you.